Students, good morning.
Good morning, sir.
So how are you people? Good? How you have written the exam, 12th exam? Was it good?
Yes, sir.
Great, great. Okay, a crash course we are starting. So one of the toughest course it is. You know why? Because 2 years syllabus we have to finish in very less amount of time. So day 1, what is lying today? What we are going to do? Units, dimensions and errors. Okay, so let's start. Because time is less, we cannot talk more in this one. We have to go in a flow and we have to finish the chapter, right? So how we are going to finish it? What we are going to minimize is the number of problems that we are seeing in the class. That will minimize. But the theory part entirely we will see, right? And then anyhow I will be giving you 30 questions to solve for practice. You solve that. Okay. So what we have basically in physics, what we do? Physics basically is the science in which we do a lot of measurements. Measurements of what? Physical quantities. What physical quantities? Mass, length, temperature, time. Whenever we go into lab, we will go and measure something. Okay. So what we measure? Physical quantities. Two types of physical quantities we have seen, right? What physical quantities we have seen? We say that first is fundamental quantities. Fundamental quantities. What are these fundamental quantities? Fundamental quantities are there means when you are measuring them, you don't have to look towards any other quantity. That means these are absolute quantities. Suppose I am measuring length, so I will simply measure length. If I have to measure mass, I will simply measure mass. I am not going to look into some other quantities. Okay. So these are fundamental quantities. These are absolute quantities. Absolute quantities. Okay. They do not depend on any other quantity. How many are there? 7. 7 absolute quantities. We all know what these are. So I am just writing them. Okay. I'm just writing them here. What are these? Number 1, say length. Second, mass. Third, time. Fourth, temperature. Fifth, current. Sixth, amount of substance. And the last one, which we do not use, okay, much, that we do not use much. What is that? Luminous intensity. Luminous intensity. That's good. These are the 7 fundamental quantities. But how we measure them? How we measure? 7, 8, 9, 10 like that. They have certain units also. Any physical quantity have two things in them. What is that? One is magnitude, another one is unit. Unit is important. So unit is what then? These fundamental quantities are there. Their units are what? That also we know very easily. We have studied them. SI unit only I am writing. Okay, meter, kg, second, Kelvin, ampere, mole, and its unit is candela. And as I said that we are not going to discuss about candela much because you can say this is not in our syllabus. Okay. So these 6 are there. Absolute quantities or fundamental quantities and their units. Other than them also there are certain things. What are those? Derived quantities. What are derived quantities? Which depends on fundamental quantities. When you are measuring them, you have to measure fundamental quantities and then get to the relation to come to this. What is the meaning? Suppose velocity. Velocity is derived quantity. Now velocity is what? First you find out that how much distance you are measuring, how much distance you have traveled, in how much time. So it depends on distance, it depends on time. Distance means length. So this depends on length and time. So this is a derived quantity. Force. So force is what? Whenever you apply the force, you are giving acceleration to the body. And according to Newton's second law, force is equal to mass into acceleration in the body. Right? So it depends on mass. Depends on acceleration. Acceleration means what? Velocity, change in velocity per unit time. Right? So it depends on many fundamental quantities. So this is derived quantity. Same way there are other, whatever you have, they are all derived, right? Because these are the absolute. So fundamental quantities are these, derived quantities are these. Okay. But there is third one also. Third one also is there. And what is third one? Supplementary quantities. What are supplementary quantities now? Supplementary quantities are also absolute. They do not depend on any of these. They are also absolute. But then why we are not keeping supplementary into these fundamental? The reason for that is they don't have dimensions. They don't have dimensions. Who? Supplementary. Okay. Supplementary quantities are not derived quantities. These are not derived quantities. And they are not fundamental quantities also. Why? Because they don't have dimensions. Okay? These are not derived quantities or fundamental quantities. Fundamental quantities. As these don't have dimensions. Now, dimension is what? We'll discuss about that, what dimensions are. Okay. So, these don't have dimensions. Whereas fundamental one, they have dimensions. We know that length dimension we write as what? L. This mass dimension what we write? M. Its dimension is T. Temperature we write as theta. Ampere we write as M, A only. Mole also we write as mole. Okay. So these are all having dimensions, but these don't have dimensions. And they don't depend on fundamental quantities also. So what are these then? These are, example of these are plane angle and solid angle. Plane angle and solid angle. Right? Now what are these? What is plane angle? What is solid angle? Okay, so let's see them. You want to note them? You note them later on. This class will be there with you. Just see the class at the moment. You all have studied this. I am just revising it. Okay, so suppose still you want to note it, you can note it. This class will be there with you. So don't worry about that. Okay, just seeing right now. Because if you are going to note it, it will take time. There will be a break in the class. The flow will be disturbed. Right? So, okay. So then, let's go ahead. Let's go ahead here. Okay. So what we have now? Supplementary quantities. Okay. So now we want to see what is plane angle. Now plane angle we all know. What is plane angle? You say no, angle subtended by arc at the center. That is plane angle only. Angle subtended by arc. This is arc. This angle. This is plane angle. This is plane angle. Same way angle we make when we make triangle. Okay. Right angle triangle will be making. This angle. This is plane angle. So can we say that the angle between two lines? Yeah, these are also two lines. These are also two lines. Okay, so angle between two lines. Is plane angle. Or you can say that angle measured in two dimensions. This is in two dimensions. Okay, two dimensional angle. Plane angle. What is its unit? Radian is there, degree is there. Okay. Radian, degree. Okay. What about dimension? Doesn't have dimension. So dimensionless quantity. Unit is there, but dimension is not there. That's why it's supplementary quantity. Okay, dimensionless. Which angle? Plane angle. Right. Then what is the other one? Other one is solid angle. What is solid angle? Solid angle is, suppose this pen is there in my hand. Okay. Now this pen, suppose I am going to rotate. I hold it from here and then I am going to rotate it like this. Okay. What shape I am going to get? I am going to get one cone. Okay. It will be a cone. It will be like this. Right. What shape we got? Cone we got. So this angle here, this is called solid angle. This is solid angle. Now I can't say that this is the angle between two lines. It is not. It is not. It's in three dimensions, like this. If I am talking about a cone, then how is the angle? Like this. This is what you have made, this way. This is solid angle. Okay, so unit is what? Its unit is steradian. Steradian. Okay, again dimensionless. Okay, length of arc by radius, right? We go previously. Length of arc by radius. This is how we measure theta. And then how we measure this one then? This, it is actually this area. Okay, by r square radius. This is r. Then this is represented with ohm. Ohm is equal to this area, covering area, but this area needs to be perpendicular to r, remember that. Okay, area by r. You don't have this much, okay, you don't have to go into this much, but just a small information. So this is solid angle. What it is called? Supplementary quantity. Okay, this is neither fundamental quantity nor derived quantity. Okay, so these are about quantities, right? The question I have to frame. One question I frame on this one. Let's see then how is the question. Question is, a quantity does not have unit. Does not have unit, but have dimension. But have dimension. Possible, not possible? Answer is not possible. Answer, not possible. Because dimension is always for a unit only. If unit itself is not there, how you will have dimension? Okay, I have written doesn't have unit but have dimension. Not possible. Correct. Okay. Second one, opposite of this, a unit, a quantity, not a physical quantity, have unit but no dimension. Possible? Since yes, possible. How? Supplementary quantity. Okay? Supplementary quantity. Supplementary quantities. Absolutely, we have it. Possible. This is not possible, this is possible. Third one, a quantity neither have unit nor dimension. Possible, not possible? Answer is yes, it's also possible. Okay. A quantity have no units and no dimensions. Possible, not possible? Answer is possible. And examples? What are the examples? Many are there. Ratios. Okay. Whichever quantity is written in ratio, like strain, longitudinal stress, longitudinal strain. Strain is what? Change in length by original length. Correct? Same way, relative density. Again a ratio. Coefficient of refractive index. Coefficient of friction. Yes. Coefficient of friction. These are what? They don't have unit, they don't have dimensions. Coefficient of refractive index, coefficient of friction, strain, relative density, which are written in ratio. All these are dimensionless as well as unitless. They don't have unit also. Okay. So questions can be framed like this. Right? And okay. And let's go back. Let's go back fast. Come on, come on. Come on. Yes. Okay. So now what we have? We have called parallax. What is this parallax? Certain questions are given on parallax, so you should know what parallax means. Okay. Related to angle. Two-dimensional angle. Okay. Now we know that if suppose I make one right angle triangle here. So right angle triangle. Okay. This is A, this is B. And this is theta. And this is hypotenuse, right? Hypotenuse, okay. Let's write it as H. Okay. So tan theta equal to what? Say A by B. We know that one. Okay. Let's look in terms of physics in this one. That means, suppose these are two things in this one. This is P and this is Q. And from here you are actually observing it. Okay, you are observing it from here. Now what you did is, you went away. Okay, same thing you are observing, but you went away. Something like this. Okay, same PQ. This is A. Now this I am writing as H dash and this is B dash. Okay, and this is angle again. This is theta dash. So now we can say that this theta dash is what? A by B dash. So can I say that this theta dash is less than this theta? Obviously. Theta dash is less than theta. Okay. So if I keep going far and far, then what will happen? Theta will keep on decreasing. Okay, that means what I am changing? I am changing this B value. So if B value you keep on increasing, you will very, very far as compared to A. Suppose B dash is very large. Not B double dash. B dash is very large as compared to A. So what will happen? This value keep on becoming less and less. And if suppose this is true, then this will become negligible. So if this becomes negligible, that means angle will become almost 0. Okay. Theta becomes negligible. Now what then? If it becomes negligible, then what? Then what? Then this h dash and this b dash will be almost equal. Okay. Theta becomes negligible. It means h dash will be almost equal to b dash. Almost equal to b dash. And how to measure then? Then we don't take tan theta. Okay, because it becomes small. Whenever angles are small, what we do? Normally we will be writing tan theta, we don't write tan theta. Theta equal to b by a, we write. Okay. Same way, in sin theta terms also we write theta equal to b by a. We will see that. Okay. But this is parallax. Now, what are we going to do with this? I am telling you one question. Okay. Let's see how to solve that question. Let's see now. Okay. Let's see the question. Question, suppose we want to measure the diameter of the moon. Okay. Or rather, diameter of the moon is given. We want to find the distance of the moon from the earth. Right. Diameter of moon is 6,400 kilometers. Okay. And parallax angle subtended by on a point on earth. How much will you take? 2 degrees equal. Okay. Not just 2 degrees. Right. So diameter of moon is 6,400 kilometer and parallax angle subtended by it on any point on the earth is 2 degrees. Find distance between moon and earth. Right. Okay. Let's start solving it. So moon is here. Moon. Okay. And any point that we are taking, suppose this is the point on the earth, we are here. So this we are trying to find. This is x for us. Diameter. So diameter is here. This is the diameter we know. Right. And this is given to us. Now what? Now the thing is, we're talking about angle. What is 2 degrees? This is 2 degrees. Now the question is, we talk about these two. These two are anyhow equal, right? So can we use parallax? Yes, we can use. This is diameter. So what you can say? Theta. Theta equal to d by x, I can say. Or if suppose that's not clear to you, no sir, we can't use it, we will go with the triangle normally we know. Okay, no problem. Use this. 1 degree. 1 degree equal to d by 2. This is d by 2. And x. Tan theta I am not using. Okay, I am directly using theta because angle is very small. Angle is very small. Okay, it's your wish. If suppose you want to write like theta by 2, this is theta by 2 equal to d by 2 by x. The same thing, no? This and this are same. I want x value. Can we get it? Yes. So theta means what? 2 degrees. So shall we write 2 degrees only? No. You have to write it in radian. You have to write it in radian. So what is the converting factor now? Okay. So 1 degree or 180 degree is actually pi radian. 180 degree is pi radian. So 1 degree equal to pi by 180 radian. 1 degree equal to pi by 2 radian. How much we have here? 2 degrees we have. So 2 into degree. Degree means 1 degree. So 1 degree means what? 2 into 1 degree. That means 2 into pi by 180 degree. Okay. So let's write that. 2 pi by 180 equal to d. What is d? There are 6,400 kilometers. So 6,400 kilometers. Let it be in kilometers. There is no problem. Okay. By x, because x is also in kilometers only we are going to get. Here it is. Just calculation. So x equal to 6,400 into 180 by 2 pi kilometers. That's the answer. Finish. This is how parallax we use. Sun also we can write. Okay. The same way, if the parallax question is coming, it will be coming like this on the moon or the sun. Okay. Right. So this was parallax. What next is there? Conversion of units. Okay. How to convert units. Right. So before that, conversion of units, let's do same conversion of angle itself. Let's solve few questions on that. Okay. So what it is? Suppose a question is asked from us. Convert 5 degree into radians. Very simple question. You know how to do it. Okay, 5 degrees means what? 5 into 1 degree. And 1 degree is what? 5 by 180 radian. Okay, so what it is? 5 by 36 radians. Okay, now suppose one question is given to you. Convert 5 degree 20 minutes into radian. Now what to do? 5 degree 20 minutes. So what we can do now? Minutes and radian ratio also, the relation we have to find, then only we can do it. Correct or not? Or this 20 minutes you convert into degrees, then also fine. So see then what we can do. Minutes equal to how many degrees? So 1 degree actually is equal to 60 minutes. And 1 minute is equal to 60 seconds, you know that. Okay, so 1 degree equal to 60 minutes. So 1 minute equal to how many degrees? 1 minute equal to 1 by 60 of a degree. How many minutes are here? 20 minutes. So 20 minutes means 20 into 1 by 60 of a degree, that means 1 by 3. Right. So this is what? I can say this is pi 1 by 3 degree. Okay. That means 16 by 3. Now I can convert it and radian. What is the problem? No, because degree I know. Okay. So what will be the answer? 16 by 3 into pi by 180. Over. Finished. So if it's coming in minutes, first convert that in degrees. And after that, it's easy for us. There is no problem. Okay. So this is how conversion of angle is done. But other than that, what are the other questions in which we convert it? Let's see that. These types of questions will be asked. Anything is possible. Okay. So then, what conversion other than this? Simple questions are there. Say what? Convert 1 Newton in CGS unit. The units are there. We didn't discuss about that. There is SI unit, there is CVS unit. Okay, we all know, that's why I didn't discuss much about it. So convert 1 Newton into CVS. Okay, 1 Newton means what? It's a force. Okay, 1 Newton means what? 1 Newton means 1 kg meter per second square. This is 1 Newton. 1 kg meter per second square. This is force equal to mass into acceleration. Okay, kg into meter per second square. Now he says what? Convert it into CGS. Okay, no problem. So when you are converting it into CGS, kg needs to be converted into gram, meter needs to be converted into centimeter, second will remain second only. We all know that. Okay. So 1 kg is 1000 gram. 1 meter is 500 centimeter and second square as it is. What we have now? 1, 2, 3, 3 zeros here, 2 zeros here. So 10 to the power 5 gram centimeter per second. Converted, it's easy. And this actually is called dyne. So 10 to the power 5. 1 Newton equal to 10 to the power 5 dyne. No problem in this one. Okay. All right. That simple questions can come. Can come. Can you make complicated? Slightly complicated. We can. What we can do is, we can change the units. We can change the units of the question. How can we do that? Suppose we frame one question. Suppose fundamental quantities we can change. Like right now we are saying no, mass is there, length is there, time is there. Okay. So those length we are measuring in meter, time you are measuring in seconds, and mass you are measuring in kg. We change it. We make it something else. Something like, if length is measured in kilometer, okay, mass is measured in gram, okay, and time in milliseconds. Now these are our basic units. This is how we are going to measure it. Okay, so what we want to do now? We want to convert 10 kg meter per second. What is this? Momentum. Mass into velocity. Convert 10 kg meter per second into new system. What is the new system? This is new system in which length is measured in kilometer, mass is measured in gram, and time in milliseconds. Alright, we'll do that same way, no change. What we did in first question, same way. So 10 kg meter per second. We have to convert that. First is mass to be converted into what? Gram. Okay. So 10 into 1000 gram. Converted mass. Means a meter is here, but he says that you want to measure it in kilometer. So 1 meter equal to what? 1 by 1000 kilometers. You know, 1 kilometer equal to what? 1000 meter. So 1 meter equal to what? 1 by 1000 of kilometer. Correct. Put it here. 1 by 1000 of a kilometer. Then what? By second. But second is time. But you want it in milliseconds. You want it to be in milliseconds. So what is the converting factor? So 1 second Okay, we want to write it in terms of milliseconds. So 1 millisecond is what? 1 millisecond is equal to 10 to the power minus 3 seconds. So 10 to the power minus 3 will bring it here. 1 millisecond by 10 to the power minus 3 equal to 1 second. So in place of 1 second, I am going to write 1 by 10 to the power minus 3 milliseconds. So 1 by 10 to the power minus 3 milliseconds. Okay, so what is there? This 1000 and this 1000 gets cancelled. Right, this 10 to the power minus 3 will go up. So what will you get? 10 to the power 4 gram, not gram only, yeah, gram kilometer per millisecond. This is the conversion of 10 kg meter per second into gram kilometer per millisecond. Okay, so a new unit is formed and we converted this thing into this new unit. Okay, so this is one thing. Now, what can be the other thing? What we can do? Right, one more question let's frame. Okay, suppose that we take basic length. Unit is normally basic length unit in SI is 1 meter. Suppose we take it as 2 meter. Okay. See, I am trying to frame one question. If basic length unit is 2 meter, then convert volume of 10 meter cube in new units. Basic length unit is 2 meter, then convert volume of 10 meter cube in new units. Okay. What to do? So new unit, let's assume that new unit is x. Okay. And x is equal to what? 2 meter. Given. Now what we have to do? This is the volume given. Now we have to convert it into new units. New unit means we have to convert it in x. So what we can see here? We can say x equal to 2 into 1 meter. 2 meter means 2 into 1 meter. So 1 meter equal to x by 2. That's it. So 10 meter cube means what? 10. 1 meter into 1 meter into 1 meter. Right? Put it here. 10. 1 meter's place. X by 2. X by 2. X by 2. 10 by 8. Okay. New unit cube, whatever that unit is. That's our answer. Okay. So like this, there will be questions on conversion of units. Okay. So these are conversion of unit questions. Right. Let's go ahead. What is next? Next is significant figures. Okay. Significant figures. We should have idea about them also. So what is significant figures? It say all non-zero digits are significant. All non-zero digits. Like example, you write 1, 2, 3, 4, 3, 6, 9. Okay. All these are significant. That means significant numbers are how many? 1, 2, 3, 4, 5, 6, 7. It says significant figures are 7 here. All non-zero digits are significant. Okay, all are significant, so significant figure is 7. 0 between non-zero digits are significant. Okay. So 1 0 1 0 2. So 0 is there between two significant figures, because this one, all non-zeros are significant. So this 0 is between significant numbers. So this 0 is also significant now. So here is 1 2 3 4 5, significant figures 5. Okay. Starting 0 is non-significant, means suppose you have 0 0 1 0 3 4. Okay, so these two zeros are non-significant. They got no meaning as far as significant figures is concerned. But this 0 is useful because it's between two significant numbers. So here significant numbers will be what? 4. Right. Then trailing 0. So for trailing 0, there are two cases. After decimal, if there is a decimal and then trailing zeros are there after that, then they are significant. That means if I write 5.00, looks like it's 5 only, right? So significant figure should be 5. No, significant figure is 3. These zeros are after decimal. So here significant figures are 3. Right? Then here without decimal, non-significant. If the same number, if I say 500, non-significant. Here significant figure will be 1. Just 1. Because trailing zeros without decimal are non-significant. But if decimal is there, this becomes significant. Because decimal says you that how much precise you are. We will see that. I am going to include in our class. Okay. So this is significant figure 3, but here significant figure is just 1. Okay. Then other than significant figures, we have rounding off. How to do rounding off? Very simple. You all know that how to do rounding off, but just let's see that. Okay. Rounding off. Now suppose that I have certain measurement I did and I got one length, okay, x equal to, let's say we got it as 1.369 centimeter or whatever, okay. So 1.369 I got. Now how will I write? I write it as if, suppose that I want to reduce it, okay, I don't want to write it up to 3 decimals, I want to write it up to 2 decimals. What I will do? It's a 1.37. I have to write up to 2 decimals. This is 3 decimals, right? All are significant? Yes, significant figures are 4. No doubt about that. No doubt. But I want to write it up to 2 decimals only. So what I did? 1.37. That means because this number here is more than 5. So I increase this by 1. I increase this by 1. We all do that. We all know that, right or not? So 1.37 we did very easily. Okay, fine. But if suppose number is 1.365 or 1.375, and again I want to write it into 2 decimals, then what I do? Here I am going to write this as 1.36 only. And here I am going to write as 1.38. Okay, this is 1.36, that is 1.38. Why? If 5 is there and before that there is odd number, we increase it by 1. Okay, if this is even, then we write it as it is. Remember that always. 1.36, this is 1.38. Very important. Rounding off. Okay, clear. One more thing I forgot, and in this thing, significant figures. If suppose that there is something like you measured it as 5 into 10 to the power minus 2, something in 10 to the power something, and then this is insignificant. This is not significant, remember that. This 10 to the power that you are writing is not significant. Trailing zeros, no? They are not significant. Remember that. Okay? Plus 2, plus 3, plus 5, plus 8. These are non-significant. Clear? So remember that these powers will be non-significant. Right? So this is rounding off we saw. Okay. Can we do any question on that? Let's see. Where these will be used is rounding off or significant figures. We have to learn how to write answer properly whenever some operations are there. What operations? If suppose it's given to us that a value, suppose a value is given to us 1.365, okay, and b value is 1.23. Okay, and I have to add it. You have to find C. C is actually A plus B. Question is find C. By using proper significant figures. Find C. So, what our method says, in any operation, let it be addition, subtraction, division, multiplication, what we have to do is answer in terms of least decimal places. Answer in terms of least decimal places. What is the meaning of that? Least significant figures. Now you see that. How many significant figures are here? 1, 2, 3, 4. 4. Here 3. So my answer will be in 3 significant figures. Or you can say after decimal 2 places. Here there are 3 numbers. Here 2. So answer in terms of least decimal places. That means 2. My answer should be in this term, like this. And okay, let's add it. What's coming? 1.365 plus 1.23, what will come? 5 here, 9, 5 and 2. 2.595. What do you write? What you have to do is you have to write it in 2 decimal places. So 2 decimal places, that means 3 significant figures. 2.595. I am writing as 2.60. Because rounding up, no, this is odd number. This is 5. So I added 1 into that. That becomes 2.60. Clear? 2 things we have used. One is this also we used, and rounding off with the 5. Previously we studied, no. So if this is odd, it will increase by 1. So I increase it. 2.60. Same thing in subtraction also. Yes, obviously in subtraction also same thing. Multiplication, division. You have to see that which digit is of least significant figures. After decimal, which is having least numbers, your answer should be in that way only. So you should know how and what the significant figures are. That's why this I told you. Clear? Okay, let's move ahead. Errors. Okay. Errors are what? We all do measurement, that's what we discuss. Okay, we are measuring this thing, that thing. So errors are likely. Obviously errors are likely. Okay. So what type of errors are there? It's a systematic error and random error. Systematic error is what? It's a device error. Device error. In device some error is there. What kind of errors will be there in device? 0 errors. 0 error is there. 0 error means what? I am not measuring anything. Suppose we are talking about ammeter. I have not connected ammeter into any circuit, but it's still showing that 1 ampere is there. Okay, that's called 0 error. Okay, mostly 0 errors we will be using in case of vernier calipers and screw gauge, that we'll see. Okay, so zero error is device error. And second systematic error type is improper technique. That means we are not using a proper technique to find a particular thing or particular measurement of particular quantity. We are not using it correctly. So obviously errors will be there. Okay, so improper technique and device error comes into systematic error. Remember again, theoretical question. Random error. What is random error? Least count error. Least count is what? Least count is the minimum measurement that you can do with any instrument. Minimum. Let's talk about a scale. Okay, one scale is there, meter scale. What is the minimum you can measure with that? 1 mm. 1 mm we can measure. And what mistake we can do in this? 1 mm. How? Because it's so close that we cannot see it properly. If 3 mm is there, make it as 4 mm, because in between nothing is there. The 3 mm can become 4 mm or 3 mm can become 2 mm because it's very close to each other. So what is the mistake we can make? 1 mm is the mistake, maximum 1 mm. It's not possible that the length is actually 5 mm and I am seeing it as 9 mm. Is it possible? Not possible. So maximum you can say either 4 you will say, one person will say 4 or other person you can say 6, or maybe you are saying correctly also 5 mm. But here we are saying that how much minimum error is possible. That's called least count error. So how much minimum you can measure with any instrument is called its least count error. So that's possible or not possible? Yes, definitely possible. Okay. So this is random error. And second one is what? Change in environment. Because of change in environment also some errors can happen. What change in environment? Suppose we are finding time period of simple pendulum. We are doing an experiment. But suppose what happened is the temperature changes, and because of temperature what happens, we know that the wire is there in which you are suspending that bob, that wire's length increases. Okay, expansion happened, linear expansion. Because of that what will happen? Time period also will change. However small it is, but it will change. Okay, so change in environment is also can have its effect. Okay, so what is random error? Least count error and change in environment. These are theoretical things that you should remember. Okay, but other than that, how we are trying to find out the errors, that also I have noted over here. Absolute error. Absolute error. What absolute error is? What is the meaning of absolute error? Okay. Absolute error means is, suppose we know exact value of any measurement. Exact value. How to find exact value? Okay, that also I'll tell you. How to come to the real value or exact value. Suppose you are doing any experiment. Okay, what is told to you? It is always told to you that take 5 readings, take 6 readings. And then what you do? You take the mean of that. That is exact value. Okay, you find the mean of that. First reading you got A1, second reading A2, third reading A3, fourth reading A4, fifth reading A5. Then you took its mean. So whatever comes out, suppose A, this is exact value. And then let's talk about absolute error. Now absolute error is what? Absolute error means is in first reading what error you did, how much is the error? Okay, say A minus A1 or A1 minus A. It doesn't make any difference to us. Okay, error is you have done more value you have found or less value you have found. It doesn't make any difference to us. Okay, error is always written like this. Okay, so A minus A1, that's absolute error in first reading. Same way A minus A2 or A2 minus A minus A3, A minus A4, A minus A5. First reading, second reading, third reading, fourth reading, fifth reading. Now, what is absolute error? We will take mean of this also. Okay. The delta A, or what? This is delta A1 plus delta A2. Suppose this is delta A1. Okay. Like this. Okay. And then finally, when the reading will come, what you will do? What you will write? Final reading will be writing as A plus minus delta A. This error is there. So whatever mean we have got, and be slightly greater than that or less than that. So this way we will be writing the final reading. This is what is the exact value. This is what possible error. Okay. Both we have taken mean. So this is absolute error for you. Then relative error. What is relative error? Relative error is absolute error by true value. It's a relative error. Delta A by A. This is why I am saying you, because this we will calculate. Okay. Questions will be asked. Percentage error. Percentage error means relative error into 100. Percentage, how we calculate? Delta A by A into 100. So questions will be asked. Okay. So these are the errors. First we saw that systematic errors, random errors, and then how we measure these errors. This is the measurement of errors: absolute error, relative error, percentage error. Okay. Okay. See down. One question I have written: a meter scale measures length as 8 centimeter. What is relative error in that? Meter scale measures length as 8 centimeter. I mean, this is exact value, true value, whatever you can say that. True value is given 8 centimeter. And he is asking what? Relative error. So where is error in that? Where is absolute error? So meter scale is there. Okay. Which error is possible in that? Least count error? Possible, no? So least count error here will become absolute error. Least count error. And what is least count error in meter scale? 1 mm. So relative error then? Absolute error, which is 1 mm, by true value. What is that? 8 centimeter. So convert both in millimeters first. So 1 mm and 8 centimeter means 80 mm. So 1 by 80. This is mm. 1 by 80 is a relative error. If he is asking percentage error, we multiply with 100. So 5 by 4, 1.25%. Okay. So this is how we can do it for meter scale. Okay. Any other question is also there. I have written propagation. I have written in this one, propagation of error. Okay. So just a minute. I will just take water and then we will start again. Right. So propagation of error means what? Now there are certain things like two quantities you are adding, subtracting, multiplying, dividing, and in measurement of all those there were errors. Then what will be the final error? That comes under propagation. So addition or subtraction. addition or subtraction. Okay, now suppose we have quantity like A. A is what? This is the real value of A plus minus. Say delta. That means relative error. Okay, there is B. B is true value, or okay, let it be fine. They are going correct. Okay, now addition or subtraction we have to do. This is the addition. C equal to actually A plus B. So we have to write that what will be the final value of C. So first thing is I have to add A plus B. So real values we will add as it is. Then what about errors? Errors also will be added. Errors also will be added. Errors are never subtracted. But anyhow, here is addition only. So I have to add it. Plus minus delta A plus delta B. Okay, let's say an example. A is equal to 3 plus minus 0.1 centimeter. Let's say. B equal to 4 plus minus 0.2 centimeter. Then find C, which is actually A plus B. So what do you do? 3 plus 4, 7 plus minus 0.1 plus 0.2 and 3 centimeter. Simple. No problem with that. Okay. Now in subtraction, if you have to do subtraction, then what? Same thing. Suppose that now D we have to find. This is A minus B. Then okay. So that will be AR minus BR. Subtraction we have to do, it to subtract. But then what? Here what? Plus minus. You will add both. Because errors are never subtracted. Errors are never subtracted. Okay? So we added here. Suppose same question. A minus B only we have to do. No, same question we have to do. What we will do? The 3 minus 4. 3 minus 1 minus 1. Then plus minus. Plus minus what? 0.3. Okay. So in addition, we are just adding the errors. Absolute errors. We are adding absolute errors in that. Okay, fine. But when we are going to talk about multiplication and division, then what we are going to do? Let's see. Okay, multiplication and division. Multiplication and division. Okay, now suppose that we have C equal to A by B. Okay, so what will happen? In this one, we talk in terms of relative error. What? Delta C by C. Relative error in this will be equal to delta A by A plus delta B by B. This is in multiplication, division I have written. Same way in multiplication also. Suppose C dash equal to A into B. So here also, delta C dash by C dash equal to delta A by A plus delta B by B. Here also, in the same way. Okay, multiplication or division, whichever is there, we are going to use relative error, and errors are never subtracted, as I told you. Here also plus, here also plus. If suppose that we want to find the quantity itself, then delta C will be what? Okay, we want to find error in that one. So delta C is error. So C into delta A by A plus delta B by B. Same way there also. Okay, let's take an example. Okay, let's take an example of that. Okay, let's take an example from resistances. Okay, suppose R1 is 3 plus minus 0.2 ohm. Okay, and R2 is 2 plus minus 0.1 ohm. Okay, they are connected in series. Series connection. They are asking us find error in total resistance. Find error in total resistance. Now we know that when we talk about series connection what happens? R equal to R1 plus R2. What else? Correct. So 3 plus 2, 5. We know that. Okay. Plus minus what? Plus minus 0.2 plus 0.3. We'll write it as RS. Now question is, let's connect them in parallel and then again find the same thing. In parallel what? In parallel what's going to happen? So parallel, what will be the resistance? We say Rp is actually R1 R2 by R1 plus R2. R1 R2 by R1 plus R2. Correct. What I'll do is, I'll write it in a different way. Is R1 R2 is R1 plus R2. R1 plus R2 is this only. So what I am going to write it as? I am going to write it as RS. Now, this is in which way? Multiplication is also there, division is also there. Then how to write that one? In terms of relative error. So, delta Rp by Rp equal to delta R1 by R1 plus delta R2 by R2 plus delta Rs by Rs. Finish. Parallel. Exactly same way for focal length you have to do. Okay, 1 by f equal to 1 by v plus 1 by u. Same thing. It will come like this only. 1 by f equal to 1 by v minus 1 by u. Come out to the same way. Okay, you have to do in the same way. Now, what is there? Delta R1. Delta R1 means is what? Where is R1 here? 0.2. Delta R1 means 0.2. R1 means 3. You will write 0.2 by 3 plus delta R2 0.1 by 2 plus delta Rs. Delta Rs also we have done 0.3 by 5. This is equal to what? Delta Rp by Rp. And what is Rp? Rp is this now. Let's put it. R1 R2. R1 R2 means 3 into 2, 6 by R1 plus R2. 3 plus 2, 5. 6 by 5, 1.2. 1.2. Calculate this all. Multiply with 1.2. That's delta Rp. Okay, these are important questions. From this chapter, how many questions are we expecting in NEET? Minimum 1. Minimum 1 definite. Maximum how many? 3. Maximum 3, minimum 1 question can be asked from this. Okay. So this is how propagation of error, that means in addition how to calculate, in subtraction how to do it, and if suppose division and multiplication is there, how to do it. Simple way I told you. Okay. And this was the difficult, one of the difficult questions, that also I told you here. Right. Then what more we can do in this? Because errors questions you will find in all the places almost. So with the power also you can see one of the question, if I can do with powers. What is next? Okay, accuracy. Okay. So one of the question we will do with power. Suppose a question is given. quantity is there, A, which is written as A to the power m, B to the power n, C to the power d. Then what will be percentage error, or what is the relative error, something like that. So relative error, what we will do, these powers are there, so m to delta A by A plus n into delta B by B plus d into delta C by C. So powers will just multiply, nothing else. Okay. Like this. And if suppose it's given in terms of percentage, you say that percentage error in measurement of A is 1%, here is 2%, here is 3%, directly will multiply m into percentage error in A plus n into percentage error in B plus d into percentage error in C. And this is what? This is equal to percentage error in A. See, relative error, if you got, that means you have to multiply 100. Here, this side also 100, here also 100. So it becomes percentage error. Simple. So m into relative error A plus n into relative error of B plus d into relative error of C. That is it. Power is there, it just multiply, nothing else you have to do. Okay. So these are also common type of questions. Right. Accuracy and precision. What is accuracy? What is precision? Accuracy means is how close to the exact value you can reach. Then you are more accurate. Suppose with the measurement you found, accurate value is, suppose G value. Okay, we calculated it is 9.8 meter per second square. And not we calculated, we know that many scientists have calculated it's this. But when we measured it, it came out to be 9.79 in lab. Very accurate, very close to this. Correct. Another person is there who measured G value 9.7889 meter per second square. Now, no doubt your accuracy is more, but his precision is more. He is giving more precisely. Okay, because he is using better instrument than you. Why? Because his least count is more. The minimum value that it can measure is less. Suppose in meter scale we have least count as 1 mm. Correct or not? Less than 1 mm can we measure? No. So if there is something in between the two lines, then what we will do? We don't know what to do. We can't say anything. But if there is certain instrument in which you can measure even less than that, so you will be more precise. Correct or not? So precision means is you have a better instrument so that you can go even more closer. That's called precision. Accuracy means how closer you are to the true value. So more precise if the instrument is, there are chances that you will be getting even more closer to the true value. That means your reading will be accurate. Okay, so that's why we say that do it precisely so that you can go to accurate value. So there is a difference between precision and accuracy. Okay, they are not same. If you are precise, it will lead you to better accuracy, more accurate result. Okay, right. Now what we have? Dimensions. Dimensions means what? Dimension means is particularly dimensions are there for all fundamental quantities, we know that. But why this dimension we study is how we are going to represent other quantities in terms of fundamental quantities. Okay, dimensions were given. Like we all know, for length we write it as L, for time we write as T, for mass we write as M, right? So how we are going to represent any other quantity, mainly derived quantities, in terms of physical quantities, we require dimensions. Okay, to express physical quantity in terms of, to express any physical quantity in terms of fundamental quantities. Fundamental quantities. Dimensions are used. Okay, and basic quantities, fundamental quantities, dimensions we already have discussed. Okay, so when you are writing any relation, suppose a relation I am using, example S equal to ut plus half at square. Okay, so dimensions of this and any quantity here will be same. Then only you can write left hand side should be equal to right hand side. So if this dimension is meter, then their dimensions also should be meter only. Then only you can write the equation. Any two quantities you are adding, their dimensions need to be same, and only you can add. I am not saying multiplication, addition. Okay, but left hand side and right hand side both should be representing same type of quantities. Then only we can add them or subtract them or write equal to. Correct? So that should be very, very clear to you. Dimensions are used for what? Again, dimensions is also used to convert one unit into another unit. Okay, one dimension into another dimension. Okay. All right. Many questions you can find on many times, rather not many questions. Many times a question will be found. They'll ask you that find the dimension of this unit, find the dimension of this quantity. Okay. So let's see. Okay, that will come on. Okay. So what dimensions? Suppose that tough one I ask. Find the dimension of resistance. Find dimension of resistance. How to find? First thing is we need to get relation. Okay, formula. Formulas are very important for us. Okay, so find dimension of resistance. So what we will do? First get the relation. Say V equal to IR. Yes, from here can I get the dimension of R? Yes, I can. This I is fundamental quantity. Ampere, I know. V, what is V? V is volt. Volt means what? Work done per unit charge. Joule per coulomb. Its unit is joule per coulomb. Joule per coulomb. This is ampere. Okay. So R we can write as joule by coulomb into ampere. So joule means what? Energy. Energy in basic fundamental units. How to write energy? M L to the power 2 T to the power minus 2. M L to the power 2 T to the power minus 2. Energy means what? Force into displacement. Half mv square you can say. Half mv square is also energy, kinetic energy. Okay. From there also you will get this dimension. Coulomb. Coulomb means what? Coulomb is what? I is there. I is what? Charge per unit time. So coulomb is I into T, that means ampere second. So this is ampere second, AT, and this is ampere only. That's it. Yes, write it properly. M L square T to the power minus 3 A to the power minus. This is the dimension of resistance. Okay, I is fundamental quantity or charge is fundamental quantity? I. Charge should be fundamental, no? Because I depends on Q. Yes, can have a debate on that. Okay, but why I was taken as fundamental quantity and not Q? Because the ease of measurement. I we can measure easily, whereas charge measurement is tough. Even though charge looks to be fundamental quantity, but we didn't take it because of the ease of measurement. I we can measure easily, so we consider this as fundamental quantity, not Q. Okay, if anybody asks you a question, you tell them. Okay. Alright, so this is dimension of resistance. Same way we can find dimensions of any quantity like capacitance also or inductance also. We can do that. But basic thing is we need to know the formula. Then only we can do it. Okay, let's move ahead. Right. If y is the force, suppose some quantity we are saying y is the force and x is length. Write dimension of second derivative of y with respect to x. Write dimension of second derivative of y with respect to x. Now what is the meaning of that? What we are going to do? Second derivative means differentiation. Like suppose displacement is x and time is there. So first derivative is dx by dt, we say velocity. Second derivative means one more time differentiation. It comes out to be acceleration. Right? This is called derivative. So here what it is? Force and length is given and he is saying that write dimension of second derivative of force with respect to length. So what I am going to do? Basically he is asking you f. Don't write f. Y. Okay. So he is asking you what y by x square. That's dimension he is asking. Derivative of y. Second derivative of y. Second derivative of y by x. Y means what? Force. And this is length square. Force means what is the dimension of force? M, L, P minus Q and L square. What is the answer? M, L to the power minus 1, P to the power minus 2. Derivative. Okay. So if derivative is there, then this is how we find the dimension. Okay. Then, okay. Common question again. You will see this in whenever you are going to do PYQs, you will find this. If force, velocity and time are fundamental quantities, that means they have changed the fundamental quantities, normally mass, length, force, velocity. Then what is the dimension of mass? How to find? Okay. So we know that in this one he says that these are the fundamental quantities. That means this is not fundamental quantity. So that means this will depend on that. This is fine. So mass depends on force. But how much power of the force? We don't know. Correct? E. Velocity. So its power is 3. Time? Power is 3. See, dimension is also used for this purpose. We said, oh, any quantity, how it is related with the fundamental quantities, that is shown by dimensions. Okay. Or how it's represented, in what power we are representing it. Power we are written. Fundamental quantities, force's power is A, velocity's power B, time's power is C. Okay. Now what? Remove this proportionality. We all know how to remove it. Bring a constant. Remaining all same. F to the power A, V to the power B, E to the power C. Now what? Write its dimensions. Mass M. M to the power 1, L to the power 0, P to the power 0. Okay, there's mass. Here also. Okay, force is what? Little while ago we don't know. M to the power 1, L to the power 1, P to the power minus power 8. Velocity, meter per second. m to the power 0 L e to the power minus 1 to the power b time. Right, what you can do now? M power is what? A, here 0, there is nothing. So m to the power a. L to the power what you can write? A, here b, there nothing. E to the power what you can write? Minus 2a, minus b, and this is plus. Now compare on two sides. Okay, m to the power a here, 1 here. Equate them. So a value 1. And then L power here is a plus b, here is 0. So a plus b equal to 0. But a you already got 1. So b value is minus 1. Then third, minus 2a minus b plus c equal to 0. Okay. Minus 2a minus b plus c equal to 0. So minus 2 into a value 1, b value minus 1, minus of minus plus 1 plus c equal to 0. So minus 2 plus 1, that is minus 1. So c value is also coming 1. So then mass, how we can write? How it is related with the fundamental quantities? You say mass is proportional to force to the power a. What is a value? 1. Velocity, velocity's power is minus 1, and time's power is 1. So m is proportional to f t by v. F t by v. Okay, this is how we will be showing the relation, right? Correct. Let's see one more. Plane angle I have done. Okay, fine. Let's do one more question. Suppose a relation is given to you. Something says P equal to E naught e to the power alpha t square plus something like beta t. Like this is given. And they ask you what is alpha, dimension of alpha and beta. What are dimensions of alpha and beta? Okay, so now this P is pressure. What you can do? This is e to the power. E means exponential. So this actually exponential's power has to be a number. It will be what? A number. Remember that. This will be a number. So that means this should be a dimensionless quantity. Alpha t square is a dimensionless quantity. It's a number. But t square is time, no? So how can it be dimensionless? How can it be dimensionless? We say alpha t square should be dimensionless, means 1. So alpha will be what? 1 by t square. That means its dimension should be 1 by t square. That means 1 by second square. Then only it can be dimensionless. Because this is second square, 1 by second square. Then only, okay. So this is alpha's dimension. Beta. Now as I told you that whenever you are writing equation, if this is pressure, this also is pressure. This is also pressure. Its dimension will be same as pressure. So dimension of beta will be what? Dimension of beta will be dimension of pressure by time. What is dimension of pressure? Pressure is what? Force by area. Okay. So what it will be? M L to the power minus 1 e to the power minus 2 by t. So beta will be M L minus 1 e to the power minus 2. Okay. Understood that? So this is about units and dimensions. Okay, one small topic is still left, that is screw gauge and vernier calipers measurement. That we will see tomorrow. Okay, so all right students, this was first class. This class will be available to you. So if you want to make notes, you make the notes. Right? All right then. See you tomorrow. Bye bye.
Thank you, sir.